Hi, this is Matt Oliver from the University of Delaware, and I am one of the many ocean scientists working on Project Swarm. In our introduction video, we thought about food, and how did food end up in a particular place like a grocery store? Well, was it because the grocery store was near a farm that produces local food, or was it because food was brought to the grocery store by a transport network like trucks and rail? Near Palmer Station in Antarctica, we also have a really rich grocery store called Palmer Canyon Hotspot. The customers are the Adelie and the Gentoo penguin, and the food is Antarctic krill that can get moved around by the currents. In Project Swarm, we have 4 major hypotheses that we want to test. And to test these, we need to use different technologies. In this video, we're going to talk about getting data from robotic gliders. Remember, the 2 main penguin species we'll be working with are Adelie and Gentoo penguins. These penguins leave their nests to forage for krill, to bring it back to their chicks to feed them. It's kind of like bringing home groceries from the store. Now, to understand the ocean or the store the penguins are shopping in, we are going to be using robotic gliders. These robots have a lot of parts to them, so we carefully prepare these instruments, and special care is needed to get them ready to do what it is they need to do. Before we put them into the ocean, we test them out in a tank to make sure that they're ready, and then we load them onto little Zodiac boats, which we then launch over the side with a big giant splash. After they're launched, they float to the surface and await their mission, and after they receive it, they dive into the depths to measure the ocean. Now, when they surface again, they communicate with us by lifting their tail out of the water to make a satellite phone call. And when their batteries are low, we drive out and pick them up. Gliders fly using the principle of buoyancy. They change their volume, becoming more or less dense than the seawater around them. They have a piston on the inside that when it sucks in, it reduces the volume of the vehicle, making the vehicle more dense, and when it pushes out, it makes the vehicle buoyant. When it gets to the surface, it communicates with satellites, which then communicates with the scientists on shore, and we also get a picture of the data that they're looking at in the ocean. Now, at Palmer Station, we will have 3 gliders operating, and they will have different missions. One glider will be a long canyon glider that will fly from Palmer Station out and across the long axis of the canyon. One will fly cross canyon, and one will be stationary, staying at one point. Now, the stationary glider in the middle measures how water changes in time. The other 2 gliders measure how the water changes in time and in space as they fly across Palmer Canyon. This is what the stationary glider looks like. We have temperature on the surface and chlorophyll on the bottom, which is a measurement of the primary producers or the phytoplankton in the region. The white dots are the depth of what's called the mixed layer. You can think of that as the depth of the effect of mixing by wind and tides, and below that is the deep part of the ocean. This black line here belongs to this axis, which is just the bottom depth under the glider. So this glider bottom depth is about 400 meters, and you can see how it changes. So in temperature, we have a nice warm surface layer, and then we have a cold middle layer, which then warms up again down here. And this water down here is called MUCDW, which stands for Modified Upper Circumpolar Deep Water, and it's thought that this water has some nutrients in it that the phytoplankton can use. And here are the phytoplankton here right now. Red colors means there's high concentrations of chlorophyll, which is the green pigment that all plants have, and blue colors are low concentrations. And so we can see most of the phytoplankton, most of the plants are up in the surface. Now, your teacher will provide you access to some glider data, and it may come to you in an Excel graph, or it may be on Google Docs. And again, this is with the metadata tab. We have pictures of where this particular glider was when it sampled. Here's a picture of the glider. Here is a glider that's being launched. And this is the description of what is in the data. So if we blow it up a little bit, we see that we have date, second since 1970, which might be helpful to you. We have water temperature both in Celsius and in Fahrenheit. We have, I'll skip this a second, we have chlorophyll concentration, which is the concentration of that pigment I was telling you about, salinity of the water, the density of the water, the current velocity of the water that the glider measures. But then we have two things. Then we have wind speed. So wind speed isn't measured by the glider, but it's from a weather station that's nearby. And then this is now the mixed layer depth, which were those white dots that I was telling you about. This thing here, this is optical backscatter. This is another way of measuring the biomass in the ocean besides phytoplankton. And so this is just an alternative way to do it. You can read a little bit about it. The units are a little bit weird, but it can be useful. So here's the data. Here is date, second since 1970, water temperature, both in Celsius and Fahrenheit, optical backscatter in inverse meters per steradian. Here's chlorophyll concentration, salinity, density, current velocity, wind speed, and the mixed layer depth. Again, this is the data. This particular data here is, you can see, is dash 0 to 10. So it's just the average. It's a time series of the average of data from 0 to 10 meters. So you notice there's no depth column in here. So what's going on here is we've taken all the data from 0 to 10 meters and averaged it, and now you have a time series. So if we look back at our sections here, if you think 0 to 10 meters, that's just this upper area. We're giving you an average of just the surface layer in temperature, in chlorophyll, in optical backscatter, and in salinity. Now, there's also another file that your teacher will share with you, which is the average between 80 and 90 meters. So it's a deep time series. And so as you're exploring the ocean, we're going to give you a time series of what it looks like at the surface, above the mixed layer, these white dots, and also what it looks like at depth, below the mixed layer. And you can see it's much warmer up here, much more phytoplankton in comparison to the deep areas between 80 and 90 meters. Even there's very, very low chlorophyll down here. And you remember what we saw before is that we have penguin depths that you can think about where they're diving in here. That will be interesting if you look at the penguin video. And as always, we have a team of scientists that are looking at the physics, the phytoplankton, the krill, and the top predators to try and answer our hypotheses. We hope that you'll partner with our outreach team to either help us answer our hypotheses or answer your own hypotheses as this data comes in.